Vertices of a triangle, they are rational points. Then what happens to centroid, incenter, circumcenter, and orthocenter? Right. So now when vertices are rational, that means what? X1, Y1, X2, Y2, X3, Y3, all three sets are rational numbers. Obviously, the centroid would be rational because centroid is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So that is 1 by 3 of sum of three rational numbers. So that is definitely rational. Right. Now, what about ortho center? Ortho center is the meeting point of altitudes. Right. So when these 3 points are rational, obviously the slopes are rational. The lines connecting the slopes are definitely rational. Right. When 3 points are rational because slope is y2 minus y1 by x2 minus y1, x2 minus x1. So y2 is rational, y1 is rational, x1 is rational, x2 is rational. So slope is rational. Right. At the same time, the midpoints of these 3 points, they are also rational. Slopes are rational, midpoints are rational. What does that mean? Altitudes are rational. Slope is rational. And what is altitude? Altitude is the line joining this point and making an angle 90 degrees with this line, right? So, for example, A, B, C, AD is the altitude, BD, B and C are rational. So this line will have rational coefficients because the slope is rational. Similarly, so this line will also have rational coefficients only and it is passing through this line. So this line is also rational. So similarly, all altitudes are rationals. At the same time, all perpendicular bisectors. Perpendicular bisectors, they also will have rational coefficients. Right. So perpendicular coefficients, perpendicular bisectors, altitudes all will have rational coefficients. So meeting point of altitudes, which is also rational. So orthocenter is also rational. Similarly, circumcenter is also rational because perpendicular bisectors are rational. But length of sides need not be rational. Right. Incenter is about ax1 plus bx2 plus cx3. Right. By a plus b plus c. But but when the points are rational, the distance between the sides need not be rational. So, for example, 0, 3, comma 4, 0 or 0, 3, comma 4, 0. This will give a rational, rational hypotenuse, right? Root 25. But instead of 4, if it is 5, then it will not give rational hypotenuse, right? So, mostly root of a square plus b square, this need not be rational. Right. So lengths of sides when vertices are rational need not be rational. Lengths of sides are generally not rational. So this incenter, which involves lengths of sides, that will not be rational. Right. That need not be rational. So the remaining these three, because this is calculation with rational numbers only. Centroid is direct one third, and circumcenter involves rational slope and rational midpoints and meeting point of two rational equations. Similarly, orthocenter also rational slope, rational point, and meeting point of equations with rational coefficients. So centroid, circumcenter, orthocenter will be rational, but not incenter. Incenter has irrational lengths of sides. That's why incenter is not rational.